Students, today we learn what are irrational numbers. Irrational numbers. So what are irrational numbers? Numbers which cannot be written in the form of p by q. Q is not equal to 0 and p, q are integers. Not. So they should not be written in the form of p by q, where p, q are integers. Such numbers are known as irrational numbers. For example, let us see square root of 2, square root of 3, square root of 5, square root of 7, square root of 8, square root of 10, and so on. They all are irrational numbers. Irrational numbers. Irrational numbers. Now, we can see from here that if suppose we take the number root 4, or say for example root of 16, root of 25, and so on, and then such numbers are not irrational numbers, because square root of 4 is 2, square root of 16 is 4, square root of 25 is 5. So what we can see from here? We can see from here that the numbers which are not perfect, the numbers which are perfect square, the square root of such numbers do not give us irrational numbers. So for a number to be irrational, the number should not be in the form of perfect square. Now we learn how to represent, say, square root of root 2 or square root of root 3, square root of root 5 on the number line. We know that we can represent any number. Any number for that means it may be rational or irrational, any real number, whole number, integer, natural number, rational, irrational, every number we can represent on the number line. So today we learn how to represent root 2 on the number line. So let us see how we can do it. Let us draw a number line. Mark the number 0 here. You can take equal interval of say 1 inch, 1 centimeter, any. 1, 2, 3, 4, minus 1. Mark a point A here. Mark point B here at 1 and draw a perpendicular from B to the line L. And what cares to be taken is that the length of AB should be equal to the length of BC. BC is, C I have marked on this perpendicular, and the length of C should be also 1 unit. So this is 1 unit. Now join A and C. So we can see that in triangle, in right triangle OBC, in right triangle OBC we can see that we can use Pythagoras theorem. AC square is equal to AB square plus BC square. So what we have got is AC square is equal to 1 square plus 1 square. Therefore AC square is equal to 2 and AC is equal to square root of 2. So what does this mean? This means that the length of AC is equal to the length of root 2. So if we have to represent root 2 on the number line, what we will do? Take a compass, put the pointer at point A and take length equal to that of AC. So put the pencil mark at point C and draw an arc. Draw an arc touching the line L at point P. So point P is the point which will represent root 2 on the number line. Point P represents root 2 on the number line. Root 2 on the number line. So again, let us recall it. What we have done basically is that we have taken a number line, taken the length of AB equal to 1, the length of BC equal to 1. Then we have applied the Pythagoras theorem, and we have used, and we have using that we have got AC equal to root 2. So this is how we represent root 2 on the number line.